At the bottom of page 3, you will find the steps for graphing a polynomial function of higher degree. Okay, so remember when we talk about higher degree, we're talking about third degree, degree 3, and bigger. Okay, so let's kind of read through these. You're going to realize that a lot of these terms may not be familiar. So we're going to read through this, and then whatever we haven't talked about yet, we'll go into detail with, and then we will come back together after we've talked about all this terminology and then start graphing polynomials, okay? So the first thing you're going to do, if you have your polynomial function of higher degree, you're going to identify the degree and leading coefficient of the polynomial function. And then you're going to use these to describe its end behavior, okay? So end behavior is something we haven't talked about yet, okay? Then you're going to determine the zeros of the polynomial function, okay? Zeros, okay, may sound unfamiliar, but zeros are the x-intercepts of the graph, okay? So zeros, that's a fancy name for x-intercepts. So basically you're going to find the x-intercepts of the polynomial function, okay? Then you're going to determine the multiplicity of each zero, okay? So that's something else we need to talk about, okay? And then you're going to use that information to determine whether the graph will cross or just touch the x-axis at each zero, okay? Then you're going to find the y-intercept, okay? So that's familiar to us. Then you're going to identify the maximum number of turning points, again, something new, okay? And then it's the last step, you're going to put everything together. You're going to plot the intercepts x and y. You're going to sketch a smooth and continuous curve that passes through these points and exhibits the required behavior at each zero and the required end behavior and abides by the maximum number of turning points, okay? So those are the steps for graphing a polynomial function of higher degree. Like I said, we need to, before we can actually start doing this, we need to go talk about what end behavior is. We need to go into detail with zeros and multiplicity, and we need to look at turning points. Okay, so we're going to do that, go into each one of those concepts individually, and then we will come back and start using these steps to graph or to do rough sketches of polynomial functions of higher degree. Okay, all right, let's first talk about end behavior. Okay, so here we go. Okay, so let me get this together. All right, so this is page 4. Okay, it's the entire page is about end behavior. Okay, the end behavior of a polynomial is a description of what happens as x becomes large in the positive or negative direction. Okay, so basically it's kind of like what's happening at the endpoints, kind of. Okay. What you need to remember for any polynomial, the end behavior is determined by the degree of the polynomial, whether it's even or odd, and the sign of the leading coefficient, okay? That is a super important statement, okay? You might want to highlight it, okay? I will highlight it here, okay? Very, very important, okay? If you're trying to determine the end behavior of a polynomial, okay, you need to look at the degree of the polynomial, whether it's even or odd, okay, and the sign of the leading coefficient, okay. All right, so if you look at page 4, okay, there are 4 boxes here. I'm just kind of scrolling through page 4 here, okay. There are 4 boxes, okay, because there are 4 different situations, okay. If you get any polynomial, if I give you any polynomial, some random polynomial, there's only 4 situations that could possibly happen for end behavior, okay? So they're all going to be summarized in the 4 boxes here, okay? So we've got, first of all, if you have an even degree polynomial, what is going to happen, okay? And then it's broken up. If you have an even degree and a positive leading coefficient, what is your polynomial? What is its end behavior going to be like? And then what happens if you have an even degree polynomial with a negative leading coefficient? What's its end behavior going to look like, okay? And then in the bottom 2 boxes, you look at odd degree, okay? And then odd degree with a positive leading coefficient, and then odd degree with a negative leading coefficient, okay? Again, when you get your polynomial and you have to figure out the end behavior, you need to look at the degree, whether it's even or odd, and the sign of the leading coefficient, whether it's positive or negative, okay? All right, let's start with an even degree polynomial, okay? We're going to talk about the end behavior, okay? All right, so we're going to start in the first box, even degree positive leading coefficient, okay? So what you need to do is think of something you've seen in this class before, the simplest thing you can think of that's even degree with a positive leading coefficient, okay? That is going to be x squared, okay? So think back to what the graph of x squared looks like, okay? X squared looks like this, okay? It is this polynomial through the origin, okay? So basically, the end behavior is what's happening at the endpoints, okay? You can kind of see we're going up this way, and then on this side, we're going up this way, okay? That is what end behavior is describing, what is happening at the endpoints, okay? Now, when you talk about end behavior, you have to talk about both directions, what's happening on the left side of this graph and what's happening on the right side of the graph, okay? So if I have this polynomial, okay, this x squared looking thing, okay, because that's what I'm relating this to. Any even degree polynomial with a positive leading coefficient is going to have this type of end behavior, okay? So I have, there's two ways you can describe the end behavior, okay? You can do it in everyday language, so just plain English, which is going to be our first bullet point. And then you can do it in a more mathematical way, which is down here, okay? We're going to start with the easy way, which is just plain English, okay? So what's happening to the left? Okay, so if we travel along the left side, it's rising. Okay, so it rises to the left, and on the right, it's also rising. Okay, so it rises left, rises right. That's how we can write this in plain English. Okay, now the mathy thing is going to be a little weird. Okay, so let's talk about that for a second. Okay, all right, so if I translated this, okay, if I gave you something like this, I would make it fill in the blank or multiple choice. You wouldn't have to write it all the way out, okay? All right, so there's two kind of statements here, okay? One is going to be for the left side, one is going to be for the right side, okay? Because when you're talking about end behavior, you have to say both directions, what is happening, okay? All right, this first part says, if your x values are approaching negative infinity, that is how you read this, as x approaches negative infinity. So that means if your x values are getting bigger and bigger in the negative direction, okay? So if your x values are getting bigger and bigger in the negative direction, okay, what is happening to the y values associated with those x values, okay? Are they getting more positive or are they getting more negative, okay? Well, these x values correspond to these y values, okay? So as your x values get more and more negative in that direction, the corresponding y values are getting more and more positive. They're going in the positive direction. So your y values will approach positive infinity. So that's what goes in that blank, okay? And then if you did the flip side, let me color code this. If you did the flip side, okay, so this is what we just did, the pink stuff, what happened on the left side. So now as your x values approach positive infinity, so as your x values are getting more and more positive, so we'd be going that way, what's happening to the associated y values, okay? Well, the associated y values are these guys. They're getting more and more positive as well, okay? So we would say the y values approach positive infinity, okay? So that's how you write it as a more mathematical kind of definition, okay? The reason I'm showing you this now, some of you guys may go on to take 1325, which is business calculus, or even 2413, which is Calc 1. This kind of notation with the arrow and the infinity or negative infinity, you're going to see that a whole lot in calculus. So I'd like you to see it, you know, kind of be introduced to it before you go on to a calculus class, okay? All right, so again, all this end behavior is meaning you're describing the what's happening at the endpoints, okay? And again, you can talk about it in everyday language, or you can give a more mathematical kind of model there, okay? So the whole point of this is, okay, if I gave you, let me give you an example. This is totally made up, okay? If I gave you the polynomial function, 7x to the 8th power minus 5x to the 3rd plus 2x plus 1, okay? This is an even degree polynomial. The degree is 8. It has a positive leading coefficient of 7, okay? You don't even have to put this thing in the calculator. You know that when you graph out this polynomial, okay, it's not going to look exactly like x squared. It's going to be a little more complicated, but you know it's going to rise to the left and it's going to rise to the right, okay? That's how this helps us, okay? All right, so let's look at the flip side. What if I have an even degree? I still have an even degree, but now I'm changing to a negative leading coefficient, okay? Again, associated with something simple, okay? What's the simplest function you've seen in this class? That is even degree negative leading coefficient, okay? Well, it's still going to be x squared. There's your even degree, but here's the negative leading coefficient, okay? So what does negative x squared look like? Well, your parent function is x squared, and then you put a negative out front. If you put a negative out front, remember, that is going to be a reflection about the x-axis. That did not go very well, but you would flip it over the x-axis, so the parabola is going to come down here, okay? So negative x squared is going to look something like this, okay? So there's negative x squared, okay? All right, so again, any polynomial that is even degree with a negative leading coefficient is going to behave this way, okay? So let's do the everyday language first, okay? Here's the left side. What is happening, okay? Well, it's falling, okay? So it falls to the left, and then what happens on the right side? It's again falling. So this guy falls left, falls right, okay? So now let's try to fill in the mathy part, okay? Again, you have to look in both directions. As x approaches negative infinity, so if your x values are getting more and more negative, so if your x values are going that way, okay, what's happening to the y values that go along with them? They're getting more and more negative, okay? So the y values approach negative infinity, okay? Then look at the flip side, okay? And then on the other side, as your x values approach positive infinity, so your x values are getting more and more positive. You're traveling in that direction, okay? What is happening to their y values? Their y values, because remember, this x value corresponds with this y value. This x value corresponds with this x value. Your x values get more and more positive. The corresponding y values get more and more negative. So the y values will approach negative infinity, okay? So that's how you write that one, okay? So again, if I gave you pretty much the same polynomial, okay, but this time I changed it to be negative 7x to the 8th minus 5x cubed plus 2x plus 1, okay, you know that since this guy is an even degree with a negative leading coefficient, that if you sketched a graph or put this in your calculator, you know it's going to fall to the left and fall to the right, okay? All right, so that's what happens if you're dealing with an even degree. So let's go spend some time on odd degree. Okay, it's going to work very similarly. Okay, so let's take a look at, let me just get this page arranged. Hang on. Okay, so let's start with odd degree, positive leading coefficient. Okay, again, you want to think basic. What's the simplest thing in this class that you've seen that has an odd degree and a positive leading coefficient? Okay, hopefully x cubed comes to mind. Okay, so let's sketch a graph of x cubed. Okay, x cubed was that long S shape that looked like this. Okay, one of the parent functions. Okay, all right, so again, any odd degree polynomial with a positive leading coefficient is going to exhibit this type of behavior. Okay, so we need to write it down. Let's use everyday language. Okay, what's happening on the left side? Okay, on the left side, it is falling. Okay, so it falls left. And then what's happening on the right side? It rises right. Okay, so any odd degree positive leading coefficient polynomial is going to fall to the left and rise to the right. Okay, now let's use the math notation to write this down. Okay, all right, so let's describe the end behavior. If your x values are approaching negative infinity, okay, so if your x values are getting more and more negative, which is this way, what is happening to their y values? Okay, well, here are their y values. They're going in this direction. They're getting more and more negative. So as your x values approach negative infinity, your y values are also going to approach negative infinity. Okay? And then as your x values approach positive infinity, okay? So if our x values are getting more and more positive, okay, what is happening to their y values? Well, they're going this way, up. So they're getting more and more positive, okay? So as your x values get more and more positive, your y values get more and more positive. So they approach positive infinity, okay? All right. So again, if I gave you some random polynomial, okay, if I gave you even just, x to the 9th minus 3x, okay, and that's my polynomial, okay? It is an odd degree, degree 9, positive leading coefficient there is 1, okay? You know this guy is going to look like this. It's going to rise to the right, fall to the left, okay? All right, last case, okay? You could have an odd degree polynomial with a negative leading coefficient, okay? Again, think basic, okay? Negative x cubed, okay? So what is the graph of this guy going to look like? Well, it's x cubed. You put a negative out front, it's going to be, x cubed is going to be reflected about the x-axis, okay? So come back over here, okay? Here's x cubed. This little piece will fold along the x-axis, so this piece will go down here, okay? And then you take this piece, you fold it over the x-axis, it's going to flip up and go up here, okay? So negative x cubed is going to look like this. Okay, so any polynomial that has an odd degree and a negative leading coefficient is going to exhibit this type of end behavior. Okay, so what's it doing to the left? Well, on the left side, it's rising. So it's going to rise to the left. Okay, and then what's it doing on the right side? On the right side, it is falling. Okay, and now we can do the more mathematical notation. Okay, so in the more mathematical notation, if your x values are approaching negative infinity, that means my x values are getting more and more negative. Okay, so using these x values, their corresponding y values are over here. Okay, so if we travel in the more and more negative x direction, our y values will get more and more positive. Okay, so the y values will approach positive infinity. Okay, and then on the flip side, if your x values are getting more and more positive, that's over here, these x values, okay, their y values are getting more and more negative, okay? So as your x values approach positive infinity, your y values approach negative infinity, okay? So those are the 4 situations, okay? And like I said, before I move on, remember, if I give you, something odd degree, negative leading coefficient, so negative 2x to the 5th plus 3x plus, or 3x squared plus x minus 1, okay? You don't even have to stick this in the calculator. You know it's odd degree, negative leading coefficient. This is what it's going to look similar to this as far as the end behavior is concerned. It's going to rise to the left. It's going to fall to the right, okay? So again, moral of the story is, okay, there's only 4 situations that could possibly happen for end behavior. Okay, for end behavior, you need to look at the degree of the polynomial, whether it's even or odd, and you need to look at the sign of the leading coefficient. Okay, and you could memorize these rules if you wanted to, or you can just memorize like the basic function associated with each one, and then just look to see if it's rising or falling to the left or rising or falling to the right. Okay. And you might want to do some practice with this mathy notation, okay? But basically, you're just trying to see, if your x values are getting more and more positive or negative, what the corresponding y values are doing, okay? All right, so let's move on to the next topic that we need to discuss, which is probably, I think it's zeros.